Alright, hello everyone. Today we're going to be talking about alkanes, alkenes, and alkynes, and what they are structurally, what they look like, and also how to name them. So you have a look at this structural diagram here, and as you can probably see, the difference between them is the type of bonds that they have. So alkanes only have single bonded carbons to hydrogens. So all of these bonds are only single bonds. So there's only carbon and hydrogen and they're all single bonded, that means it's an alkane. If we look at alkene, only difference here is that we have a double bond in between the two carbons, which makes it an alkene. There's still only carbon and hydrogen, but it's got a double bond. Now, alkyne, triple bond. So the carbons are triple bonded together. Now, as far as naming goes, it's very helpful to understand how to name alkanes, because naming alkanes is kind of the starting point for when you name more complex organic molecules as well. So the first step, which is the same for many other molecular structures and classes, is you count the number of carbons in the carbon chain, in the longest carbon chain. So for the ones above, we only have 2 carbons in all of these carbon chains. So they're all going to have, so we go down the number of carbons is 2, they're going to have the prefix eth. And we can see that for all of these, the start of the name is eth. Eth means 2. So 2 carbons in the carbon chain. Alright, now the part that changes is the suffix, or the end of it. So you can see for alkanes, suffix is ane, alkene, ene, alkyne, ine. So it's quite easy to remember based on what the actual molecule is, whether it's an alkane, alkene, alkyne, as to what the suffix is. So the suffix will depend on the functional group, and that's the same for all organic molecules. So for alkane, the suffix is quite easy. It's ane, alkene, ene, alkyne, ine. So that's why these are all ethane, top left, ethene, top right, and ethine is the one down here. Now they're all can be very different when we go to more complicated molecules. But let's go through another quick example of a hydrocarbon, and then we have to name it. Now let's look at this one. So the start is always the same. We count the number of carbons in the carbon chain. So how many have we got? We got 1, 2, 3, 4. 4 prefix is bute, so that's the start of it. Now the suffix, if we go up here, and we have a double bond here. So there's a double bond, which means that it's going to be an alkene. Now, this one's a little bit more difficult because we actually have to say the position of that double bond in the carbon chain. So we actually have to number these carbons. So we'll number them 1, 2, 3, 4. Okay, now we already did this when we counted, but now we're just labeling them. So this double bond, we say it's on the first carbon. So we say that this carbon here has the double bond. Alright, that's carbon 1. So we have to indicate, we put that 1 out the front. Alright, 1 bute, and we said it was an alkene, so 1 butene. Now the reason why we have to say this number is because let's imagine that this double bond is on the second carbon. So I'll just do a quick diagram here. Just pretend that there is hydrogens at all of these. Alright, so if we have that double bond on this second carbon, then they're a different molecule, okay? So if it was on the second carbon, then it would be named differently as well. It would be 2-butene. Alright, but if this double bond was on this one, it would actually be the same molecule as this one here, just in the reverse order. So if it is the same, then it has the same name, if it's on the first or the last carbon, that double bond. We'll go through some more examples of these, but for now, it's a quick introduction to hydrocarbons, alkanes, alkenes, and alkynes.